All right. Number one, we got parallelogram PAWS. S is 124, and we got to find the other angles. What do we know about the angles in a parallelogram? We have two different rules that go with it. Give me one fact about angles in a parallelogram. What do you know about the opposite angles in a parallelogram? They're congruent. What do we know about angles that are next to each other in a parallelogram? They equal 180. So if S is 124, notice I don't care that my picture doesn't really show 124 angle. All I need to know is what angles are across from each other and what angles are next to each other. So across from the S has to be angle A. So I know angle A has to be the same. Next to S is the P and the W. So if you can look at the letters, you can see A and S are opposite, which means the other ones are next to. So I have to do 180 minus 124, which gives you 56 for both W and P. Okay, so the work there is drawing yourself a picture, making sure when you label the picture, you go either clockwise or counterclockwise around that shape. Don't jump. It's not PA up on top and then come back to the left for W. You can't do that. You got to go all the way around the shape. All right, number two is the one that has a bunch of information beyond what's just on the picture because there's not enough space on the picture for me to draw everything. Over to the right, it tells me AX is 4, so I know that segment is 4. It tells me BD, this entire diagonal, is 16. And angle DCB, what's the vertex of angle DCB? Which one? I'm sorry. DCB. It's 110. What's the vertex of the angle? C. So I start at D, I go to C, and I get to B. So this entire angle here is 110. So then how much is angle DAB? Start at D, get to A, go over to B. How much does that whole angle have to be? 110, because it's opposite. Opposite angles are congruent. So I know that one's 110. All right, then angle ADC, where's the vertex of that? D. Start at A, go to D, come over to C. That's this entire angle. How much does that entire angle have to be? 70. Perfect, because your angles that are next to each other have to add up to 180. So those two are the exact same rules you used on number one. All right, now that I know all of angle ADC is 70, how am I going to find angle 1? Perfect. 70 minus 30 is? Sorry, 70 minus 32. Thank you. 38 there for angle 1. Because they got to add up to 70 total. All right, angle 2. 32, why? Nice. So we got the Z thing going on here, alternate interior angles. So it's bottom 32 has to be that top one for angle 2. Then what's angle 3? All right, so then I need BC. Now I lost where my letters are. BC is over here. How much that got to be? 6, because opposite side congruent. How about DC, which is down here? 10. Opposite sides are congruent. XC is right here. 4, because the diagonals do what to each other? Bisect. Nice. Which means AC, that entire segment is 8. Nice. And then DX, so this bottom left side of my diagonal. 8, because your whole thing is 16, and you're cutting it in half. Okay, so that kind of runs you through all the different parallelogram rules. So as you're looking at one of those pictures, and this is what it will look like on your test as well, you have to go through and run through all of those facts in your head to find the different angles. So when you know it's a parallelogram, we have all those facts. When we're trying to find out if it's a parallelogram, we got to work backwards from those facts. Remember, we've got 6 different things that you can use to say things are parallelograms. Opposite sides parallel, opposite sides congruent, opposite angles congruent, angles that are next to each other add up to 180. That's all stuff we just used. diagonals bisecting each other, also what we just used. And then there was the one extra one that had a little bit of a tweak. Those first 5, you had to have 2 pairs of each of them to be able to say it's a parallelogram. The last one, you can have 1 pair that's parallel and congruent. Okay, so on this picture, what do we see right away? Yes, it's a parallelogram. Why? Yeah. Well, I only have 1 pair of them. True. So I'd have to have a little extra work to be able to say opposite angles are congruent because I only have 1 pair of that. Is there a way I can do this without having to show any extra work? What? What do you know about these two? Do they? Absolutely. And these two? So we can say angles next to each other equal 180. Now, if you wrote that they were opposite angles congruent, you need to show why that last angle is 95. How would I figure out this angle? What work would I do to get how much that angle is? Say it louder for me. Ooh, I can't do the 180 minus it because that assumes that it's a parallelogram. What shape is it to start with? Before we define it as a parallelogram. 4 sides. Broad group, 4 sides. Quadrilateral. How many degrees in a quadrilateral? 360. So if you want to use this one, you got to do the work of 360 minus all of these to show that it's 95. Then you could say opposite angles are congruent. But you can't just put the 95 in there because to just put it in there assumes that there's parallel sides without actually checking to see if there's parallel sides. So your better bet, the one you don't have to show any work for, is angles that are next to each other equal 180. The one to do opposite angles congruent, you got to show the extra 360 minus all your angles. Good? All right, so then you've got number 4, where you're naming an angle bisector, a median, a perpendicular bisector, or an altitude. I'm going from a vertex perpendicular to the opposite side. Which one is it? Chapter 5 coming back at you. Altitude, nice. The next one, I'm going from a vertex to what appears to be a midpoint of the opposite side. Not bisecting the angle, I'm bisecting a side. So it's a median. There you go. The opposite side. All right, true or false, diagonal of a parallelogram is a line of symmetry. So you can fold a parallelogram. Can I fold that and have them match up on each other? Depends on what? Depends on how you fold it. Can I fold here and have this corner get all the way over there? No. So that is a false statement. Diagonals are not a line of symmetry in a parallelogram. All right, last but not least, to determine a student's overall test score for the semester, she deletes the lowest test score and calculates the average of the remaining test scores. Took all 5 tests, got 62, 78, 83, 86, 93. What overall score did he earn? What do you do? All 5 of them? Got to read a little closer. How did she calculate her grade? Yeah. There you go. Delete the lowest score, so we're getting rid of that. So you need to, at the minimum, you're telling me what 78 plus 83 plus 86 plus 93 is. because then we need to take that, we need to divide it by 4. Or you could show me that formula. I don't care, but you got to do something, show me some work on this problem to show how you calculate it. So what'd you get? 85. So the key on that one, because everybody knows how to find an average, right? You all know you add up all the numbers and divide by the number of numbers. The key on this one is reading, because you have to read that that first sentence to know that she gets rid of the lowest score, to take that out before you do the average. So when you're doing these ACTs, pre-ACTs, make sure you slow down and you actually read for understanding that information. Might be one of those moments when you want to underline important things in your sentence, like I did. Deletes the lowest test score. So knowing that's highlighted might be important later as I'm reading. I like deleting something seems like a big deal. So I'm going to underline it so I remember that it happens. All right, when you are done, 100% correct work shown on the ACT. If you did opposite angles are congruent on number 3, you need work with it. Everything else is pretty much just straight answers. Then you can put your name on and pass it in. All right, today we go a little to our other special parallelograms, starting with a rhombus. So, is a rhombus a parallelogram? Are the opposite sides parallel in a parallelogram? Or I'm sorry, are the opposite sides parallel in a rhombus? Yes? Okay. What do we know then about the opposite sides? They're congruent. So we know opposite sides are parallel. We know opposite sides are congruent. All of these are in a rhombus because it's a parallelogram. What do we know about opposite angles? What do we know about angles that are next to each other? Equal 180. What do we know about the diagonals? There we go. So knowing that a rhombus is a parallelogram tells me that it has all the parallelogram properties. Remember, with those parallelogram properties, you just got to remember that you can spin a parallelogram 180 degrees and have it match up on itself, and it tells you all of those things are true. What makes a rhombus a rhombus? What's special about a rhombus? Back to your Ed puzzle information. That one special quality. If you're not sure, maybe you take out your Ed puzzle notes and check. What makes a rhombus a rhombus? You could look at the flow chart. The marks are on the flow chart, but if you're looking at your Ed puzzle notes, we pretty much said it as one of the two qualities. There's 2. What's special about a rhombus? Four congruent sides. So we already know it's a parallelogram, but what makes it a rhombus is it's got to have all the sides congruent. All right, so we're going to go through those same questions we went through with the parallelogram. We're going to ask ourselves, can you fold a rhombus and have it overlap perfectly? So I have a rhombus in my hands. All four sides are equal. Can I fold this and have it match up on itself? Where? Where do you want me to fold? Hot dog, hamburger, or diagonal? Which one? Either. Okay. Here. Oh, so you want me to fold the diagonal? Gotcha. So yes, there's a line of symmetry, yes? Okay. Either diagonal I can fold it on, but I cannot fold it hot dog or hamburger. Right? Okay, so yes. On your diagonals. So if that's true, if I'm folding on the diagonal, what do you know about angle 1 and angle 2? What do I know about angle 1 and angle 2? They're congruent. Okay, will that happen in every corner? If I fold on the diagonal, will the sides of that angle be congruent? Okay, so what do we know happens to the angles? They got bisected. Diagonals bisect angles. The diagonals bisect angles. Did that happen in the parallelogram? No. I'm going to flip back here real quick. Right here. That was definitely not bisected, right? It was a 38 and 32. But because my diagonals are lines of symmetry, now my diagonals bisect angles. What can you tell me about angles 3 and 4? They equal 180. Absolutely. What else do I know about them? They're what? They're congruent. So if they're congruent and they equal 180, so if we have those two diagonals meeting here in the center of my rhombus, creating 90-degree angles, what are the diagonals to each other? What kind of lines make right angles? Perpendicular. So your diagonals are perpendicular. Did that happen in the parallelogram? Think back to your homework. One of your parallelograms in your homework had this angle as 72, and this one is 108. They're not perpendicular, right? So the perpendicular, the diagonals getting, or those angles being the same, those come from the fact that it's a rhombus and we have that line of symmetry when you fold on the diagonal. Okay, so now we have 3 extra properties. Parallelogram properties all still exist, but now we have all 4 sides equal, diagonals bisect angles, and diagonals are perpendicular. So when I look at this next picture and it tells me it's a rhombus, how much is angle 1 going to be? 50. Nice. Because your diagonals bisect the angles. Remember, when you do this on your test, I'm not expecting the reason. I'm just expecting the 50. I'm putting the reason up here now for your notes so that when you go back and look at your notes when you're doing your homework, you're not like, I have no idea where this number came from. That's why I put those extra notes on it. That's why you should put them in your notes. All right, how about angle 2? 50. Why? Nice. Alternate interior, which means angle 3 is also 50. All of them diagonals bisecting the angles. Or you can use that alternate interior to get either one of 2 or 3. All right, then I need to know angle DAB. Where's the vertex of angle DAB? A. So I start at D, I go to A, I get to B. I want this entire angle in that lower left-hand corner. What do we know about angles that are next to each other? They equal 180. How much is angle ADC? ADC. How much is this angle? How much is angle DAB? 80. Nice. All right, so then how much is angle 4? 40. Nice. It's bisected again. What is angle 5? What are those diagonals? How do the diagonals meet? 90s, because the diagonals are perpendicular to each other. All right, so we got a rhombus again on the next side. How's PO going to be? 10. Nice. Because all your sides are congruent. How about PM? Come on. 10. Nice, because all your sides are congruent. How about NQ? 6, I heard. Absolutely, because your diagonals bisect each other. That came from the parallelogram. I'm going to put EO for each other. Okay, how about MQ? 8, I heard. Absolutely. Again, diagonals bisect each other. MO? 16, because you're adding them together. Okay, so are the diagonals of the rhombus congruent? We got to know. Why not? Use the last example. Okay, well, in the last example, if I can recreate it, how long did MO was? I heard 16. How long is NP? 12. Are they congruent? No, they're different. Other way to look at it is think about if this distance going across, if I rotated it onto here, would it be the same? Harder to see on the visual, easier to see with the actual numbers on that last example. They do not have to be the same. Good? All right. So we want to know what is congruent to each in the rhombus. So at your tables right now, go ahead and find out what other things are congruent to angle 1 in that picture. What other things are congruent to angle DEC? DEC, that vertex is E. So DEC, we're looking for things that are congruent to that angle. And then what's congruent to DE and what's congruent to DC. Go ahead and find those at your table. Go. Three for all but DE. So 3 angles to go with angle 1, 3 angles to go with angle DEC, and 3 segments to go with segment DC. All right. It's a rhombus. So what do we know the diagonals do to the angles? Bisect. Okay, so what is angle 1 congruent to if that angle is bisected? Think about what you did back. Where'd it go? Here. What did we know about those two spots? So what's angle 1 congruent to? Angle 2. Because that angle got bisected. Now, what other angles do we know those two are congruent to? Angle 5 and angle 6. You've got opposite angles that are congruent. They're both cut in half. You could say alternate interior to get to those two. It doesn't matter. But we know that it's the same amount for all of angle A and all of angle C, and that same amount got cut in half. So all 4 of those are equal. Angle DEC is this angle right here in the center. What else is it congruent to? First of all, how many is it? How many degrees? 180 for multiple, but what about just this angle? 90 is, we know that's a 90. What else is a 90? If that one's 90, what else is 90? AED, absolutely. So that's this one. Give me another one. AEB, that's this one. Give me one more. DEC, that's this one. All right, segment DE. What is this segment congruent to? BE, perfect. There's only one for that. Then I want segment DC. What is segment DC congruent to? AB, absolutely, because opposite sides are congruent. What else? DA and BC, because all sides are congruent. Okay, so why did I do that? I wanted you to run through those rhombus properties in your head to kind of get them down pat. Those are the new ones. The fact that all 4 sides are congruent, the diagonals bisect the angles, and the diagonals are perpendicular to each other. Those are the new properties that just work for rhombuses or rhombi. Good? All right, so find x in the rhombus. The angles are labeled. So when you're looking at that picture and you see the arrow there, it's telling me that that angle is 3x minus 10. What are we going to do to be able to find x here? Yeah. Does just this angle plus this angle equal 180? No. We add a little bit, though. What can we do? Say again. Add another x. Close. Which angles add up to 180? Angles that are where? Next to each other or across? So this entire angle plus this entire angle adds up to 180. What do you know this is? What do you know this is? So let's tweak that equation that you gave me. What's going to add up to 180? I'm hearing it. 2x plus 2x, I think I heard. And? Absolutely. I'm not going to have us take the time to go through the algebra on it. I just wanted to write that equation, but I want to write another equation as well. We know this angle, 90. So could you write a different equation? What do you know triangles add up to? So what equation can I write for that triangle? So there are multiple ways to get at the x for this. It doesn't have to be one or the other. It's just which thing did you see first? Do you see the triangle? Go with the triangle, knowing that that center angle has to be a 90 because our diagonals were perpendicularly bisecting. If it is the angles next to each other adding up to 180, just make sure you double it so that you've got both of those angles together to get to the whole thing. Good? All right, so we're going to go down to that thing. And we're going to talk about parallelograms again. This time I want to know if a rectangle is a parallelogram. Are opposite sides parallel? Yes? So rectangle is a parallelogram, which means that parallelogram or that rectangle has all the parallelogram rules. So what do I know about opposite sides besides being parallel? Absolutely. Now you're probably getting sick of writing these, but the more we write them, the more they get in your head. What do we know about opposite angles in a parallelogram? What do we know about angles that are next to each other? What do we know about angles that are next to? Equal 180. What do we know about diagonals? Bisect each other. I'm going to create that by each other thing again. To each other. Just to make it faster, bisect it to EO. Okay, so we know rectangles have all the properties of the parallelogram. What makes a rectangle a rectangle? What's special about a rectangle? I'll give you a hint. It's related to the angles. All the angles are 90 degrees. Okay, we're going to go back and answer that is a rectangle or rhombus question in a moment. But I wanted to make sure we had down what makes a rectangle is that it is a right angle. Or it has 4 right angles. Is a rectangle a rhombus? Does it have 4 equal sides? No. Okay. So there's not 4 equal sides. At least not guaranteed, right? Could it have? Sure, but it doesn't have to have. So when we talk about is a rectangle a rhombus, we're looking at does it have to have all the properties of a rhombus? And it does not, because it doesn't have to have 4 equal sides. But it does have 4 right angles. Can I fold the rectangle and have it match up on itself? Okay, so not on our diagonal, agreed. Could I fold that hot dog or hamburger and have it match up? Yes. Your vertical and your horizontal. So a picture that we've got there, those dashed lines in there are my lines of symmetry. So if that is the case, what is AX congruent to? I'll fold, is that hot dog? I'll fold hot dog. What is AX congruent to if I fold down? DX. So AX was congruent to DX. What if I folded the other way? What would AX be congruent to? BX. Okay. Now let's look at CX instead. So CX down here in the bottom, if I fold hot dog again, so I fold on the horizontal, what is CX congruent to? BX. And what is CX congruent to if I fold the other way? BX. So if AX is 6, what do we know? What else is 6? DX, BX, and CX. So how long do I know my diagonals are? How long is AC? How long is DB? So what do we know about the diagonals in a rectangle? What are they? Congruent. Perfect. Was that true in a rhombus? No, because remember we had that example right here. We had one diagonal was 16, one diagonal was 12. So it's special for a rectangle because of our lines of symmetry. All right, what do we know about angles 1 and 2? Where are 1 and 2? 1 and 2. They're congruent, absolutely, because if you fold on that line of symmetry, 1 and 2 end up on top of each other. What about 3 and 4? Also congruent, that same line of symmetry. So the line of symmetry is super important because anything because of the line of symmetry is congruent. So in this particular case, we're just talking about the angles that overlap from the line of symmetry. Okay if I write LOS for line of symmetry? Yeah? Okay. Angles that overlap from the line of symmetry are congruent. And that's basically true no matter what shape you're looking at, right? If we found a line of symmetry, the pieces on either side of the line of symmetry have to be the same. Okay, so remember that diagonals are not lines of symmetry for a rectangle. They are lines of symmetry for a rhombus. But remember, visuals, not on a rectangle. So when you look at your next piece, parts are, you got to think about where are my lines of symmetry. All right, so in this picture, I know AC is 20. That whole diagonal is 20. How long is BC, this side? 12, because your opposite sides are congruent. How about AB? Perfect. Opposite sides congruent again. How about DB? 20, because your diagonals are congruent. How about AO? 10, because your diagonals bisect each other. How about CO? 10. How about DO? Absolutely. All of those because the diagonal bisects each other. So when you're looking at what am I going to have to do for a test on this chapter, you're looking at it. You're going to get a picture. I'm going to tell you which shape it is, and you've got to be able to fill in the missing pieces. What angles measures are, what segments lengths are, same idea. So I could combine these two pictures, the one on the left and the one on the right. I could put them all into one problem where you got to find all the missing angles and the missing sides and lengths of diagonals. How much is angle 1 going to be in this next picture? Say it again. You were right. 32. Somebody else tell me why it's 32. Because of the line of symmetry. If I folded this straight down the middle vertically, 32 and 1 would end up on top of each other. All right, how are we going to get angle 2? Is it 90? No, definitely not 90 because that was for a rhombus, not for a rectangle. How are we going to get it? we've got a triangle there. And you know you have 32 and 32, which is 64. So if I do 180 minus 64, what is that, 116 you said? Okay. All right, it's 116. How are we going to get angle 3? Very nice. We got these two right next to each other. 180 minus the 116, which is 64. Perfect. How are we going to get 4? Yeah. I don't think you want these. I don't think these two equal 180. What does that whole angle equal? How much? 90. It's a rectangle. So I don't think you want to subtract from 180. You want to subtract from, yep. So how much is angle 4? 58. All right, if that's 58, how much is angle 5? Fold the other way. How much does angle 5 have to be? 58. Line of symmetry. These two are the same. Okay, how about angle 6? 58. And there you're talking whichever line of symmetry you want to use. If you go this direction, that 58's got to be the same as out there. Or you could do 90 minus 32. Yeah. So it all just depends on which thing you see first. All right, so when you've turned to the next page, I just want to leave this up here real quick. Do diagonals bisect the angles in a rectangle? Look right here. Do diagonals bisect the angles? If I have too much stuff on there, this is 58 and this is 32. Is that angle bisected? What does bisect mean? Cut into equal parts. Is that cut into equal parts? No. So do diagonals bisect the angles in a rectangle? No. I'm going to go back to my example again. Are the diagonals perpendicular? Right here. Do we have 90s? 116 and 64. Not 90s. Not perpendicular. All right. We've got a rectangle in this next picture. RSTW is, or RWTS is a rectangle. We want to find X. If RZ is X plus 2, so just here, and SW is 3X minus 14. What kind of equation can we set up for that? What do you know about the diagonals? 2 facts. They're congruent. Love it. One thing we know that 2 diagonals are congruent. The diagonals are SW and RT. I know they're congruent because it's a rectangle. What else do I know about the diagonals? They bisect each other, absolutely. So do we know some other piece of this picture that's not on there? ZT. How long does ZT got to be? Okay, what can we do with those 2 facts? Set them equal. What do I have to do to get this whole RT? I heard it. X plus 2 plus X plus 2 gives me all of RT. We know SW is 3X minus 14. Are we good? Because if we can just set up the equation, I don't think we really need to solve it because you guys know how to do algebra. Are you okay on where the equation came from? Diagonals bisect each other, so this x plus 2's got to be the same as that one. And then they're equal to each other, so we add up x plus 2 and x plus 2 to get all of our t. We set it equal to 3x minus 14. All right, where's the square located on the quadrilateral flow chart? The bottom. So my next group of questions runs you through all of the things we've learned so far. Is a square a parallelogram? Are the opposite sides parallel? Yes, which means you know opposite sides are also congruent. Absolutely. What do we know about opposite angles? Congruent. If it makes you feel better, this is the last time you're writing out these lists for today. What do we know about angles that are next to each other? And what do we know about diagonals? Bisect. And again, I'm going to put EO for each other. All right, is a square a rhombus? Are all four sides congruent? Yes, so that it has the rhombus properties. For a rhombus, again, we have all four sides equal, or all sides congruent. What did we find out about those diagonals? What did the diagonals do to the angles? Nice. And what are the diagonals to each other? How did they meet? They made a specific angle. They made right angles, so what are they to each other? Perpendicular. Okay, so those are the new rules that we got today specifically for a rhombus. Is a rhombus a rectangle? I'm sorry, is a square a rectangle? Yes. So we've got four right angles. What do we know about those diagonals? What are they to each other? Used it on that example with RWTS. Congruent. And what do we know about things that overlap from a line of symmetry? Congruent. So if you're looking for one-stop studying opportunity, this page is kind of helpful in that it has all of the different properties of your parallelogram, rectangle, and rhombus all on it because the square has all of them. So if you're looking for something to help you with studying, that's the spot to go. All right, so at your tables right now, knowing all of the 3 or 4 different things we're talking about here, we've got rectangles, rhombuses, squares, 3 things. I want you to look at those descriptions and decide which shape it is, rectangle, rhombus, or square, or multiple if there's multiple. So go ahead and talk at your tables. after the first one? Yes. When are the diagonals perpendicular? When are the diagonals perpendicular? Okay. When are they congruent? Okay. So this number, or the second one, says they have to be perpendicular like a rhombus, but not congruent. You are correct. Before. Yes. Okay. You okay? Rectangle, rhombus, or square. No parallelograms. All right, diagonals are congruent but not perpendicular. When are they congruent? What shape? Rectangle. When are they perpendicular? Rhombus. So what shape is a rectangle but not a rhombus? Go for the obvious. A rectangle. All right, the next one, we got diagonals that are perpendicular but not congruent. That's a rhombus. All right, perpendicular and congruent. That's when it's a square because it's got both properties. All right, diagonals bisect the angles and are not congruent. Which shape has some bisecting angles? I heard square and I heard parallelogram. Look back on the previous side. Does the parallelogram have bisect angles? Look at the other side. The rhombus has bisecting the angles. Parallelogram bisects each other. That's why we had that EO there. But bisecting the angles, that's a rhombus. We don't want congruent, so we don't want rectangle. So it can't be a square, it's got to be that rhombus. Because bisecting the angles goes with rhombus. All right, a few more to go. We okay here? All right, I need to know angle 1 in this picture. It is a square. I heard 90, absolutely, because your diagonals are perpendicular. Okay, how about angle 2? Go bigger picture. How much is that whole angle? 90. I heard it back there. 45. Your diagonals bisect your angles. So you had to cut that 90 in half. So you had to recognize it's a square. It gives you 90-degree corners. We cut that one in half. All right, the next one. We're going to find x, y, and z. Again, it's a square. Give me any fact you know. Three x does equal 6y. I will agree. Can we use those when I have two different variables? No. So we got to have something else we know about 3x and something else we know about 6y. Look at the last picture. What do we know about this piece? It's 45. So what do I know about this piece? It's 45. For both of them. Both of them have to be 45 because they're both half of that angle. And it's a square, so that's a right angle. Okay, we can solve this one out. What's x? And what's y? Okay? So we've taken care of x and y. We got to find z now. Z is inside of angle 1. It's a what? It does equal a 90. So I know angle 1 is 90, which means I can just plug that in. 90 equals 3z plus 6. What do we do to solve? Minus 6. 84 is 3z. And what is z? 28. Good. Thank you. Questions? All right, last picture there. I've changed the shape on you. It's a rhombus. Okay, so think your rhombus rules, previous page if you want it open. How much is angle 1 going to be? 90, I heard absolutely, because your diagonals are perpendicular. How about angle 2? So rhombus, the diagonal 2.